So the good news about solving logarithmic equations, or equations with logarithms in them, is the steps are very similar to kind of what we did with solving equations with exponentials, like we did, yesterday. So let me start out kind of with an example here. And let's say we've got 5 plus 2 times the natural log of x equals 4. Okay, so it's a logarithmic equation. It's an equation with a logarithm in it. Okay, so first thing we want to do in a situation when we have logarithmic equations is we want to combine multiple logs into one log on both sides. Okay, so I'll make that fit. There we go. Of course, that's not the situation that we have here, right? We already have just a single logarithm. So if we had multiple logarithms on the left-hand side, we want to try and use our log properties to get those together. And if we had multiple logarithms on the right-hand side, again, we were going to use our log properties to get those logarithms together. All right, but since we only have one here, we're going to skip step 1 here. All right, but then step 2, we want to isolate the log. All right, so in this case, we want to isolate natural log of x. So to do that, we're going to subtract 5 from both sides. So 2 natural log x equals -1, right? Divide both sides by 2. So natural log of x equals -1/2. Okay, so we've isolated the log. The log is now by itself. The natural log there is by itself. Okay. And so how might we go about? Of course, again, if we had our calculators, we could graph the left-hand side, graph the right-hand side, find the point of intersection, find the x-coordinate of the point of intersection. But how might we go about trying to solve this from this point without a calculator? What could we do to both sides here, Shelby, to cancel it out?
Put the natural log of x, like, as the exponent.
Yes, so we're going to do e to the power of the left-hand side equals e to the power of the right-hand side. That's right. So we're going to raise both sides to be powers of the log's base. Okay, I don't really have an eloquent way to say what I just said there. That's pretty ugly too. But essentially we're just going to do e to the left-hand side and e to the right-hand side. Because natural log is a log base e, so we're going to do e to the natural log equals e to the -1/2. The beauty of that is e to the natural log of x is what? X. It cancels out and leaves just x. And then e to the -1/2, well, that's our solution. Okay? Or if you wanted to, you could say, 1 over e to the 1/2 if you wanted to, or something like that. But that is our answer. Okay. That's our solution. And of course, we can check this, right, just to make sure here. So let's see. I can take my calculator. Oh, there's no easy way to do this. All right, so one thing I like to do, right, when I'm substituting stuff in, sometimes e to the -1/2 is like weird to like substitute back into something. So what I like to do instead is type e to the -1/2 in my calculator like that, hit enter, and then I like to store it in for x, right? So I don't know if I showed, I'm pretty sure I've shown this before, but if not, you can press the stow button, right? It takes your answer and a little arrow there, and we can store it into a variable. The most easily accessible variable here is x, so I'm just going to push the x. So now whenever I press the x button, it uses that value, e to the -1/2. So I could do 2x, and it'll be twice e to the -1/2. I can do natural log of x, and it'll be -1/2, because the natural log of e to the -1/2 would be -1/2. And so now to check this, I can just plug it back into my equation here. So 5 plus 2 natural log of x, which is what I want. Okay? So we know that our answer is right there. Okay? E to the -1/2 is correct. To do it, anytime you want to store any value, so again, I wanted to store e to the -1/2. So I like to type it in, and in fact, anyway, if you press, once I typed it in there, hit enter, I can press the store button, okay, and that puts that little arrow up. So it's going to take this value here, which is e to the negative 1/2, and I can store it in any variable. If you notice here, right, I have all the letters of the alphabet in green, if you can barely see them, right, A, B, C, and you could hit like alpha A, and then anytime you use that letter A in your home screen, it'll use e to the negative 1/2. But the most accessible one is the X. So I just like, because X is just, you push the button, there's no alpha necessary. So you hit enter, and boom, now it's stored in for X. Only for the home screen, right? So if I go back to like y equals and I type like 100x, it's not going to use the x from the home screen, it's going to just use the variable x. So that won't affect things. But there's that, yeah.
So if you like still like A,
Mm-hmm.
and use the level, like instead of y equals, do like
That's possible. I don't know. You have to check on that. That could be possible though. A might then be used. Yeah, you might go then use A. Yes, that's possible. I would imagine so. But anyway, that's helpful to then go back and check with these. Okay. So 4, and one thing we do need to do is to check for extraneous solutions, solutions that maybe don't work. Like we solved and we got x equals this number. But if it doesn't make the equation true up here, then it's no good. Okay? And specifically, we're looking for things because remember that the natural log, we can't just take the natural log of any number that we want, right? We didn't have to worry about this for exponentials because you can do a number to any power, any number power, right? You can do a number to a negative power, you can do a number to a positive power. But can we take the natural log, or can we take any log of a negative number? And the answer is no, right? Logarithms have domain restrictions. You can only take logarithms of positive numbers, not even 0, right? Sorry, yes. Okay. So you want to look for any values that would end up with you taking the logarithm of a negative number. That's what you really want to look for. But here, this one works, so it's not a problem. E to the negative 1/2 is positive, so natural log of that will be fine, and we'll be good from there. All right, let's try another one here. Natural log x minus 2 plus natural log 2x minus 3 equals 2 natural log x. So here we do have that situation from step 1. We have multiple logs on the left-hand side, so we want to combine those together. Since we have addition between them, what will that result in if we put it in a single logarithm? Multiplication, right? So we're going to end up with natural log of the quantity x minus 2 times 2x minus 3 equals then 2 times the natural log of x. Of course, I kind of did something silly here. What should I really do to the right-hand side here?
divide by 2.
Well, if we divide by 2, that's just going to move the 2 over to the left-hand side. But what can we do instead, though? Yeah, put the 2 up in the exponent. That's what we should probably do here. Just so we get it all in terms of a single logarithm over here and a single logarithm over here. Okay, so now we're all in terms of one single logarithm. All right, well, we could, I guess, kind of isolate things if we wanted to here, but at this point, since we have natural log on both sides, what can we do now to cancel things out? E again, that's right. So we'll do e to the natural log of that and e to the natural log of that. And again, the e to the natural log, their inverses, they cancel out. We're left with x minus 2 times 2x minus 3 equal to x squared. So at this point, well, we need to like multiply this out, right? So we get 2x squared, let's see here, minus 4x minus 3x, so minus 7x plus 6 equals x squared. Right, and what should we do from here? Subtract that x squared over, that's right. X squared minus 7x plus 6 equals 0, which, oh my factors. So we get x equals 6, x equals 1. So let's check these in here. You know, so is 6 going to give us any problems? Well, we're going to do 6 minus 2, so it'll be natural log of 4. That's not a problem. 2 times 6 is 12, minus 3 is 9, so natural log of 9 equals then 2 times natural log of 6. Doesn't seem like we're going to have any issues there. But if we plug in 1, it'll be natural log of 1 minus 2, which will be natural log of negative 1. Can't take natural log of negative 1. So x equals 1 is not a solution. Okay, it does not work. It's not part of the, x equal to 1 is not part of the domain there. So yeah,
How'd you get from x versus 0?
I subtracted the x squared from both sides. It was 2x squared, so I subtracted x squared. Yeah. Thank you for asking. Yeah, sometimes, guys, if I ever skip like too many steps, let me know. But I also don't want to like insult your intelligence and like put like the plus 3 on both sides and put the line, the way you originally learned it, kind of thing. So, yeah. But please, 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 like Megan just did there. If you're ever like, where did you go? Let me know, and I will be happy to explain that stuff because sometimes I do. The 1? So the idea is that these solutions, while we result with these solutions, they need to make the original equation true, right? Like they need to work back in the original equation. 1, if I plug it back into the original equation here, I'm going to have 1 minus 2, which is negative 1, and then the natural log of negative 1. Well, we can't take the log of a negative number. And again, think about this. If I try to take the natural log of negative 1, okay, I'm not sure what that equals, right? So I'll say, well, I'm not sure what it equals. Let me rewrite. Remember that natural log is really log base e. And so I'm trying to answer the question, okay, if I rewrite this in exponential form, e to what power gives me negative 1? But that is impossible, right? Because you can't take a positive number like e, raise it to a power, and get a negative value. So that's why negative 1 the 1 we have to throw out because it results in us taking the natural log of a negative number. Whereas Caleb with the 6 minus 2, no problem, it's 4. We can take the natural log of 4. 2 times 6 is 12, minus 3 is 9, natural log of 9, no problem. Natural log of 6, no problem. 6 will work. If you actually plug it into your calculator and evaluate that, the left hand and the right hand side will be the same. Okay? So, does that answer your question? Okay. So, let me do one more here, and then I'll have you guys try one on your own. And then we're done. All right, let's do log base 3 of z minus 3 equals 2. Okay, log base 3 of z minus 3 equals 2. So again, the first step here, not necessary, right? There's not multiple logs for us to combine together. This is a single logarithm. There's no other logs for us to put together with it, so we just have one already. All right. Also, the logarithm is already isolated, so step 2 is also done for us, right? We don't have to worry about isolating. It's by itself. It's log base 3 of some stuff equals 2. And so then the next step, how can we go about canceling out log base 3? Should we do e and e here? No, right? So we use 3, right? Because the base now is 3. So we want to use 3 to cancel that out. So we'll do 3 to the log base 3 of z minus 3 equals 3 to the 2. Okay, and so we're left with z minus 3 equals 3 to the 2 is 9. So we add 3 to both sides, and we get z equals 12. Okay, so z equals 12 there. That's something you can maybe have figured out by guessing and checking or something like that, or not guessing, right? But rewriting in exponential form. You could have even rewritten that in exponential form and gone from there too. So, anyways.
Wait, how'd you get 3 to the side? Oh,
Good. Okay. All right. Try this one. Log base 4 of x minus a log base 4 of x plus 1 equals 1/2. feel free to use your calculator if you need to convince yourself that you're right. Alright, so let's go to Julia F. What were you able to come up with here, Julia? Or what'd you do? Okay. Okay, or x plus 1, right? Yeah. Mm-hmm. Okay, so you did 4 to the power of both sides and to cancel things out. Okay, sorry, I just want to make sure I'm keeping up with you here. So those cancel out. We're left with x over x plus 1. And 4 to the 1/2 you said was 2. Good. Okay.
And then we multiply by x plus 1 to get 2x plus 2 equals x.
Okay.
And subtract 2x, so a negative x equals positive 2, so x equals negative 2.
Okay. All right. And so did you check your answer? It doesn't work. Because it can't even the log of a negative. So what's the answer here? There is no answer. No solution. Yes, James.
Question if this works. I still got no solution, but instead of combining the logarithms,
Mhm.
I just made all the terms the degree of 4. So I had 4 to the power of log base 4 of x minus 4 to the power of log base 4 of x plus 1 equals 2. Is that still a way to evaluate it, or do I need to combine the logarithms before I do that?
I don't think, while you still maybe would result in a no solution here, I don't think that you can you did. All right, hang on. Let me see what. So did you say? Let's see here if I can. Right up here. Are you saying you did like 4 to the entire left-hand side?
I did 4 to the log base 4 of x minus 4 to the log base 4 of x plus 1.
Oh, like this. Oops, I should probably finish writing the word log there. Okay, x plus 1. So you did it like this.
Yeah, so I ended up with x minus 1 equals 2, which results in negative 1 equals 2, which is never true. But I don't know
Right.
if that always works.
I don't think this will be true. I don't think this is not quite right here, and it's because of the subtraction there. I think that's what throws me off. Now I don't have an easy way to like show you that it's not true, but I don't think that's going to quite work. You want to get it in terms of one logarithm there.
Okay.
So yeah. Yes. I mean, I could say just in general. Well, okay, yeah, I'll go down here a little bit. I think maybe to kind of convince you here, right? If I had like 3 minus 2, we know that that's going to equal 1. But if I do 4 to the third minus 4 to the 2, but that's not quite. That's not quite the same thing. I think that you're asking. I'll think about this for a little bit. I think I can figure out something that would show you that that's not going to be necessarily the right thing. But we'll hold off on that right now. So yeah. Okay. Anyway. So there it is. Yes. No solution. Any other questions? That's it. Okay. That is it.